Okay, now let's think about the forecast error. Here there are many ways to measure the forecast error. One of the ways you can use the mean absolute deviation and the tracking signal. And also I'm going to briefly talk about mean absolute percent error. But mainly the mean absolute deviation MAD and tracking signal, these are the main focus of today's lecture. And this the process is basically try to find out the tracking signal. So actually there is a more simpler way to measure the mean absolute deviation. But for the sake of showing the tracking signal, you know the process is kind of in this case a little complex. But in the later spreadsheet, I will introduce a more simpler way to measure the mean absolute deviation. Okay, here is the so tracking signal is basically the whether your forecast average is you know the working properly, working correctly or not. So if a tracking signal is beyond -3 or +3, then you need to somehow revisit your forecast method because that constantly provide a biased forecast. So that way is a good way to measure your tracking, your forecasting method is good or biased or not. So number one here, there's actual demand, and they assume that our demand forecast is 1,000 units over the 6 period of time. So let's find out the deviation. Deviation is actually your actual demands minus forecast value. So compared to your forecast, how your actual demand is deviated from your forecast. So it should be actual demands minus forecast. That will be a negative value means your actual demand is less than your forecasted demands. And positive means your actual demand is actually greater than your forecasted demands. The next column is the running sum of forecast errors. Simply you can use the current deviation, then current deviation plus the next deviation. That way you can running sum of forecast errors. And the absolute deviation, you are taking the absolute value of this deviation. So negative sign will be gone. So using the absolute ABS, absolute value function, then deviation. So it should be all positive. Only focus on the, error. How much error is there between the actual demands and demand forecast? Then same thing, you can use the sum of absolute deviation. Then you use the mean absolute deviation. The mean absolute deviation is the sum of absolute deviation divided by your time variable. Okay? Then copy the formula. Actually, mean absolute deviation can be calculated more, more easily. But this is the way you can try to find out tracking signal. So I'm showing more complicated way here. So this is your accumulated mean absolute deviation. If you want to use a simpler way, then you can use here absolute deviation in a column. And simply you can find out the average value of all the absolute deviation. Then that should be the exact same as your accumulated mean absolute deviation. Okay, anyway. The tracking signal is the running sum of forecast error here divided by mean absolute deviation for each month. So -1 all the way to positive 3.30, right? So that's the, when you look at the graph below, the tracking signal is between -1 to between -1 and positive 3.30. It goes here and here, right? That's the range of tracking signals. And as you show here, the ideal tracking signal is like a 0, but usually it's okay to have negative 3 and positive 3. So look at this graph closely. The tracking signals, starting from negative 1, and then it's changing over period of time, all the way to positive 3.3. Sorry. Let's kind of analyze this tracking signal. So the forecast here was off by how many units? 66.7 units based on mean absolute deviation. Okay, and the tracking signal was equal to 3.3 mean absolute deviation, right? So mean absolute deviation, MAD. So according to our rule of thumb, yes, it was not acceptable. The forecasting model is not acceptable because it's beyond the positive 3, right? And it drifted from negative MAD, negative 1 MAD to positive 3.3 MAD. And then why this happened? Because the actual demands, you see the actual demands. Actual demands was greater than the forecast in actually 4 or 5 of 6 period. You see the almost like a 5 period are greater than actual demand or greater than forecast, right? This is positive, tracking signal means actual demands exceed forecast value, so it's greater than forecast, meaning that it is under forecasted, constantly under forecasted. Forecasting value is constantly low. Somehow the trend will be continued to rise, then it will be problematic. Okay, so somehow based on the tracking signal here we found, we may revisit the forecast method because of the under forecasted biased forecast here based on tracking signal. We can revisit it. Okay, that's the value of tracking signal. So in the next lecture, I will use some of the sample forecasting problems to explain what we learned so far: the simple moving average, weighted moving average, exponential smoothing, regression line, and decomposition of method and tracking signals. I will explain how to solve the problem using those methods. Thank you.